Hi everyone, myself P. Praveena. I am the Assistant Professor of Mathematics in Institute of Aeronautical Engineering topic. Today I want to discuss about the topic of normal form of a matrix. Normal form of a matrix. Okay. Before going through that, previously we discussed about the concept of echelon form and basic concept of the rank. These two and normal form, these two are basic concept of the rank and echelon form and normal form. These are all useful for finding the rank of a matrix. First, in that first video, I discussed about the rank of a basic concept of a rank of a matrix, and that in the second video I discussed about the echelon form. That is also one of the method for finding the rank of a matrix. And now I want to discuss about the one more method for finding the rank of a matrix, that is normal form. Okay, first I'll discuss with the concept of that. Every m by n matrix of rank R can be reduced to the form of IARE 0, 0, 0. Okay. Here, every matrix can be reduced as a one identity matrix form. That is IARE 0, 0, 0 or directly IR or IR 0 or IR 0 form. Okay, we have to reduce the given matrix as identity with respect to the row and column operations. Here we have to apply both row and column operations. After getting that identity, that order of the rank of a matrix. That order of R is a rank of the matrix. This is the concept of the normal form. Okay, once again I'll discuss. Every m by n matrix of rank R can be reduced to the form of IR 0, 0, 0 or IR 0 or IR 0 by a finite number of elements transformations, where IR is the row unit matrix. That R is called as the rank of the given matrix. Here we have to apply both row and column operations for the normal form. Okay, I want to discuss with one question for this. First question, reduce the matrix A is equal to 1021, 2132, 1313 to its normal form and hence determine its rank. Once observe, what about the given matrix? This is number of rows. How many? Number of rows 3 and number of columns 4. That means, is it rectangular matrix or square matrix? This is rectangular matrix. Okay. For that, what's the concept of the normal form? We have to reduce the matrix as identity with respect to row and column operations. For that, first I am using row operations with respect to R1. Okay, with respect to R1, I'll make it as R2 first element and R3 first elements are zeros. Okay, I'm using the row operations. With that, I'm reducing as first element in R2 and first element is R3 as zeros. Okay, for that, I'm using the row operations there. Okay, here, what about the R1 first element? That R1 first element as 1. R1 first element as 1 and R2 first element as 2. R2 first element as 2 and R3 first element as 1. Okay. With respect to this, I'll make it as 2 and 1 are zeros. For that, I'm using the row operations, that is R2 tends to R2 minus 2R1. R2 minus 2R1. Next operation, R3 tends to R3 minus 3R1. So, R3 minus R1 only. R3 minus R1. Here not 2. Why? Because here R1 first element as 1 and R3 first element as 1. For that, here the first two operation is R2 minus 2R1 and R3 is R3 minus R1. From that, there is no changes in the first row. That is directly 1, 0, to 1, and the second row, I'll make it as second row first element as 0 with respect to what? R1. For that row operation, R2 tends to R2 minus 2R1. That means what? 2 minus 2 into 1, that is 0. Next, 1 minus 0, that is 1. Next, 3 minus 4, that is minus 1. And the last one here, 2, 1 into 2, that means 2 minus 2 is 0. Okay, with respect to R1, R2 row completely changed and their first element as 0. Next, similarly, with respect to again R1, I'll make it as R3 first element as 0. For that row operation is R3 tends to R3 minus R1. For that, 1 minus 1, 0. And next, 3 minus 0, 3. And 1 minus 2, minus 1. And 3 minus 1, 2. 3 minus 1, 2. Okay. With respect to row operations, then completely R2 first element and R3 first elements are zeros. And now we have to verify what about the next possibility. Okay. For that, I'm taking the column operations. What about the previous matrix there? 1, 0, 1, 0, 2, 1, and 0, 1, minus 1, 0, and minus 1, 0, and 0, 3, minus 1, 2. Okay, this is the previous matrix. From that, I'll make it as C1, C2 first element, C3 first element, and C4 first elements are zeros with respect to the columns. But directly here, no need to convert C2 first element as 0. Why? Because directly there, C2 first element as 0 only. Okay. Then I'll make it as C3 first element and C4 first elements are zeros. From that, I'm using the column operations with respect to C1. That is C3 tends to C3 minus 2C1. And the next column operation, C4 tends to C4 minus C1. Okay. If you are using these two directly, that first element and the first element in C3, C4 are zeros. For that, how we are writing that matrix form? That is 1, 0, 0, 0, 1, 3. There are no changes in C1 and C2. And now the changes in C3 with respect to C1. For that, what about the row operation? C3 minus 2C1. That means 2 minus 2 into 1, 0. Next, what about the next value? Minus 1 plus 0. Minus 1 plus 0. That is minus 1. Next, minus 1 plus 0. That is minus 1. Now the completely third column is changed. And next, with respect to C1, I'll make it as C4 first element as 0. For that row operation, column operation, C4 minus C1. For that, C4 minus C1 means 1 minus 1, 0. Next, 0 minus 0, 0. And next, 2 minus 0 is 2. Okay. Then once observe, after using the row and column operations there, in that R2, R3 first elements are zeros and there C2, C3, C4 first elements are zeros. In that identity matrix means what about the first column and first row? In that first column as 1, 0, 0 form and in the first row as 1, 0, 0 form. That means here first row and first column will be reduced as identity, row and column matrix. Okay, now the next possibility is there. Okay, here the next possibility with respect to R2. I'll make it as R3 as 0. R3 as 0. For that, what about the row operation? R3 tends to R3 minus 3R2. R3 tends to R3 minus 3R2. For that, okay, 1, 0, 0, 0, there, 0, 1, minus 1, 0. There is no changes in R1 and R2, only the changes in R3 with respect to what? R2. That means here, 0 minus 0, 0, R3, 3 minus 3, 0, and next 2, here minus 1, sorry, here minus 1 and plus 3, minus 1 plus 3, that is 2. And the next 2 minus 0. That is 2. Therefore, with respect to R2, I'll make it as R3 second element as 0. Okay, that's the row operation. And next, what about the next possibility there? Here observe in R3 row. Here I'll take 2 common. That means R3 divides 2. R3 divides 2. From that, once observe, after dividing with 2, that is 1, 0, 0, 0, 0, 1 minus 1, 0 there, 0, 0, 1 and 1. That means R3 divides 2, we get that is 0, 0, 1, 1 from the R3. And next possibility, once observe there, what about the next possibility? Here I'll take column operation. Okay, once observe, with respect to C2, I'll make it as minus 1 as 0. With respect to C2, I'll make it as minus 1 as 0. For that, what about the row column operation? C3 tends to C3 plus C2. C3 tends to C3 plus C2. Once observe, I'll write here that matrix 1, 0, 1, 0, 0, 0, 0, there, 0, 0. And next 1, minus 1, 0, 1, minus 1, 0. And next 0, 0, 1, 1. 0, 0, 1, 1. Okay, for this, I'll make it as minus 1 as 0 with respect to what? Column. What is that column? C2 column. That means here I'm adding C3 plus C2. That means 1 minus 1 is what? 0. For that 1, 0, 0, 0, 1, 0 and there 0. C3 plus C2. 0 plus 0, 0 and 1 minus 1. 1 minus 1, 0 and the next column here, next, that is 0 plus 1, 1. Okay. Now the changes in C3 with respect to what? C2. Okay. And there is no changes in C4. Directly write down 0, 0, 1. 0, 0, 1. And here after that the next possibility. Okay. This I'll make it as this 1 as 0 with respect to what? C3. That means what about the row operation? C4 tends to C4 minus C3. C4 tends to C4 minus C3. For that 1, 0, 0. No changes in C1, C2 and C3. Now only the changes in C4 with respect to what? C4, C3. That means 1, 0, 0, 0, 1, 0 and the next column also no changes, that is 0, 0, 1 with respect to now that C3. Okay, that is 0 plus 0, 0, 0 plus 0, 0 and 1 minus 1. Not plus 0 minus 0, 0 and 0 minus 0, 0 and 1 minus 1 is 0. Okay, then after using with respect to C3, C4 column is completely 0. Therefore, now the matrix will be reduced as, okay, identity. Then I'll write it as this. 1, 0, 0, 0, 1, 0. There 0, 0, 1 and 0, 0, 0 form. Okay, that is this. Okay, therefore, which is in the form of I3 and a complete column as 0. That is I3 is 0 form. Therefore, after applying the row and column operations, now the given question will be reduced as identity matrix. What about the identity matrix form there? I3, 0. Therefore, rank of the matrix, that I3, that means order of the identity matrix is equal to rank of the matrix, that is 3. Therefore, A is reduced to normal form I3, 0. Hence, rank of the matrix is 3. Okay. This is the procedure for finding rank of the matrix by using normal form. Okay. And next, I'll give one more question. That is normal form or canonical form. Okay. What about one more name for the normal form? That is canonical. That is canonical form. Okay. Same as the last question. Okay. By reduce the matrix into normal form. What about the matrix there? 1, 2, 3, 4, 2, 1, 4, 3. And the last row 3, 0, 5, minus 10. For that, we have to find a rank by using normal or one more name for that, canonical form. Once observe, previously we discussed with the rectangular matrix. Now once observe the given question, what about the order of the matrix? Here number of rows 3 and the number of columns also 3. Therefore this is comes under square matrix. Okay, whatever it is, then it is rectangular or square, same procedure for the any matrix. Okay, but here I'm using square matrix for finding rank of the matrix by using normal form. For that procedure, given matrix 1 2 3 4 2 1 4 3 3 0 5 minus 10. Okay, what about the order of the matrix? This is square matrix, that is 3 by 3 matrix. For that again I'll make it as 2 and 3 are zeros with respect to what? 1. With respect to 1. That means what about the row operations for that? That is, I'll write it there. That is R2 tends to R2 minus 2R1. With respect to 1, I'll make it as 2. That means we have to multiply that 1 with what? 2. That means R2 subtract with R1 and that R1 is multiplied with what? R2. Okay, that is the first row operation. And similarly, I'll make it as 3. R3 first element as 0 with respect to what? R1. For that row operation, R3 tends to R3 minus 3R1. R3 minus 3R1. For that, what about the row operations there? First one is R2 tends to R2 minus 2R1 and another one is R3 tends to R3 minus 3R1. For that, how the matrix change? Once observe there is no changes in the first row, that is 1 2 3 4. There also 1 2 3 4. Now the changes in R2 with respect to what? R1. For that, R2 minus 2R1 means 2 minus 2, this is 0. Next, minus 3 minus 4. 1 2 into minus 2. 1 minus 4, this is minus 3. And next, 4 3 into minus 2. 4 minus 6. 4 minus 6, that is minus 2. And next, similarly here 3 minus 4 into 2. 3 minus 8, that is minus 5. 3, once observe there, 3 minus 4 into 2, that is minus 5. There minus 5. Okay, this is the second row with respect to R1. Next, similarly, third row with respect to R1 again, that is R3 minus 3R1. That means here, what about R3 first element? 3 minus 3 into 1. 3 minus 3 is 0. This is the first value. And next one, R3 second element as 0 minus 3 into R1 second element as 2. That is minus 6. This is minus 6. And similarly, R3 third element 5 minus 3 into R1 third element 9. 5 minus 9, that is minus 4. This is minus 4. And similarly, last element, that is minus 10. There minus 10 minus 3 into 4. Minus 10 minus 12, that is minus 22. Okay. Therefore, with respect to R1, I'll make it as R3 first element as 0 and the remaining are minus 6, minus 4 and minus 2. After using the row operations now, R2 first element 0 and R3 first element is 0. Next procedure here, once observe in R3. Once observe here in R3, there 2 is common. In R3, 2 is common. For that, I'll divide R3 row completely with what? Minus 2. That means this is 1, 2, 3, 4, 0, minus 3, minus 2, minus 5. And dividing with minus 2 means there minus 6 is divides. 2 means that is 3. Minus 2, that is 3. And minus 4 is divides with minus 2, that is 2. And minus 22 is divides with 2, that is 11. Okay, then if you are having any common terms in the complete row, then we can take common. Here the common term is -2 with the, in R3. Then directly I will take the common. After that we get 0, 3, 2 and 11. Next possibility. And next, with respect to again row operations, I'll make it as R3, second element as 0 with respect to what? R2. That is, what about the matrix there? 1, 2, 3, 4. Next 0, -3, -2, -5. And next 0, 3, 2, 11. 0, 3 to 11. For that, I will make it as these 3 as 0. Depends on the question. Not only have to follow the same row or column operations. If you want to reduce 2, 3, 4 as 0 with respect to column operations means, then you can follow that. Or else here the possibility to make 3 as 0 with respect to row. That's why I'm using there here row operation. Okay. For that, here call row operation for that. Here R3 tends to R3 plus R2. R3 plus R2. From that, here after using that row operation, there is no changes in the first row, that is 1, 2, 3, 4, and there is no changes in the second row, that is 0, -3, -2 and -5. Now the changes in R3 with respect to what? R2. That means R3 plus R2 means 3 minus 3, 0. Next, 2 minus 2 is 0. And next, 11 minus 5 as 6. 11 minus 5 as 6. Therefore, with respect to row, then completely R3 as first element as 0 and second element as 0, and similarly third also 0. We get the fourth element as 6. Okay. And the next possibility after using that, and next possibility, I'll make it as 2, 3, 4 are zeros with respect to C1. C1. For that, what about the column operations there? That is C2 tends to C2 minus 2C1. Next, C3 tends to C3 minus 3C1. And C4 tends to C4 minus 4C1. Okay, once observe, with respect to C1, I'll make it 2, 3, 4 are zeros. For that column operation, 2 minus 2, and this is 0. This is 0. And 3 minus 3 means this is 0. And 4 minus 4 means that is 0. For that column operations, these are the column operations. Now applying that means C2 minus 2C1 means there is no changes in the first column. Then directly write down, that is 1, 0, 0. Yes, this is 1. This is 1, 0, 0. And the next column with respect to C1, that means 2 minus 2, 0. Next, minus 3 minus 0, minus 3. The next, 0 minus 0, 0. Similarly, here in the third column with respect to C1, 3 minus 3, there 0. And minus 2 minus 0, that is minus 2. 0 minus 0, 0. And similarly, there 4 minus 4, 0. And minus 5 minus 0, minus 5. And 6 minus 0, 6. After applying the column operations, then C1, C2, C3 first elements are zeros. Next. Okay, next possibility there. Next possibility, maybe here I'll make it as minus 2 and minus 5 as 0 with respect to what? C2 second element. For that, I'm using the column operations. Then here see, same. That means I'll make it as minus 2 and minus 5 are zeros with respect to what? Minus 3. For that column operation, 3C3. First I'll write it as that matrix there. 1, 0, 0, 0. Next 0. Minus 3, minus 2, minus 5. Next 0, 0, 0, 6. Okay, from that, with respect to this, I'll make it as minus 2 and minus 5 are zeros. For that, what about the column operations? C3 tends to 3C3 minus 2C2. And C4 tends to 3C4 minus 5C2. Okay, for that, now I'll write it as that matrix after using that column operations. There is no changes in the first column, that is 1, 0, 0. And the second column also no changes. Then directly write down 0 minus 3, 0. Now, it changes in C3 with respect to C2. that is 0 minus 0, 0, 0 there, and here 0 minus 0, 0, this, and minus 2 into 3 and minus 3 into 2. That means 3 into minus 2, minus 2 into minus 3. There 6 minus 6, 6 plus minus 6 plus 6 is 0. This is 0. And next, similarly, there 0. C3 is 0 and C2 is 0. 0 minus 0, 0. Okay, that is the third column. And similarly, next C4 with respect to C2, that is 0 minus 0, 0. Next element here, minus 5 into 3 minus 5 into minus 3. Okay, that is minus 15 plus 15. This is 0. Therefore, this is 0. And next, similarly, last one, C4. That means tends to 3C4. That means 3 6 are 18 minus 0, that is 18. Okay, then here after getting this, after using the column operations, then the matrix will be 1 0 0 0 0 minus 3 0 0 0 0 0 18. Now once observe in the second column and the third column there, C2 divides minus 3. I'm taking common minus 3 from the C2 and I'm taking commons from the C4 18. That means C2 divides minus 3 and C4 divides 18. Then after taking common, then the matrix will reduce as 1 0 0 0 1 0 0 0 and 0 0 1. From that I'll write it as this 1 0 0 0 1 0 0 0 1 0 0 0. Then this is equal to what? This is also identity matrix, that is I3 0 form. This is I3 0 form. Therefore, the given square matrix after using the row and column operations, it reduced as identity with order as 3. With order as 3. Therefore, the rank of the matrix, the rank of A is equal to how much? 3. Therefore, the given matrix rank is equal to 3. This is the procedure for the normal form for the square matrix. In the previous question, we discussed with the rectangular matrix. Okay. Next, these are the similar questions for solving. Reduce the matrix as A is equal to 0, 1, 2, 1 and 1, 2, 3, 4, 3, 1, 1, 3 into normal form. And the second question, 1 minus 1, 2 minus 3, 4, 1, 0, 2, 0, 3, 1, 4 and 0, 1, 0, 2. These are the two practice questions for finding rank of the matrix by using the normal form. Okay, this is the concept by using normal form for finding the rank of a matrix. Okay, thank you. Next class we will discuss with some other topics from the syllabus. Okay, thank you. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.